Alright, so z-scores. Z-score tells you the number of standard deviations away from the mean. Positive is above mean, negative is below. So when we make this chart, like we made, so we said on this chart, we said like go one standard deviation to the right. If you went one standard deviation to the right, that means z equals 1. If you went two standard deviations to the right, that means z equals 2. So these are essentially z-scores that we wrote on this empirical rule thing that we did up here. But not everyone's going to fall right on one of those lines. You can get a z-score of 1.25 or negative 6.3. So a large positive z-score would be looking way over there. A slightly positive z-score somewhere in here. Slightly negative, and then like it's really negative. So it's just telling you how far away you are from the mean and also the direction you're going. So the formula is z equals x bar minus mu over sigma, which is the data point minus the mean over the standard deviation. Same formula, I'm just writing out in words instead of symbols. And then this is what we start translating things into to work with, and I'll show you how to work with this like in your calculator tomorrow. Anyway. So there are 4 variables in that equation. I can give you any 3 of them and ask you to find the rest. So we start figuring out like some math with that. Let's say x bar equals 15, mean equals 10, standard deviation equals 2. And then I'll say find the z-score. Some of these you could just kind of look at, and you almost, this formula is kind of intuitive, like it makes sense to you, I think, what's going on. So if the mean is 10, and we're at 15, we're 5 away from the mean, right? And every 2 is a standard deviation. So how many standard deviations away are we? 2.5. And if you do the math, that works out also, but some of you I think can just kind of do this intuitively. So if I go z equals x bar minus mu over standard deviation, x bar in this case is 15, the mean is 10, so my distance from the mean is 5, and then I got to divide that by how big a standard deviation is, which in this case is 2. And so z is 2.5, so z is 2.5, puts me right in here, and then we'll start working with that. What percent of the data is above that? What percent of the data is below that? What percent is between this and negative 2.5 maybe? But we're kind of locked in right now to this 1, 2, and 3, and this allows us to do stuff in the middle. It's not right on one of those standard deviations. So I could give you, say, like I could give you the z-score. So the z-score is negative 2. Mu is 100. Standard deviation is 5. Find x bar. I'll give you a second to try that, and I'll go through it. And you can kind of think through it. You can use the formula, or sketching a graph might help you. I'll talk about all those when I do it. This one lands right on one of the numbers. If you made a graph, or just in your head, like thought about a quick graph, your mean's 100, Your standard deviation is 5. And this z-score equals -2 is just telling you go 2 standard deviations to the left. So if this is your mean, and you go 1, 2 standard deviations to the left, you should land at 90, right? If you use your formula, z equals x bar minus mu over sigma, you'll get -2 equals x bar minus 100 over 5. I think I would multiply both sides by 5, so I get -10 equals x bar minus 100. And then add 100 to both sides. You'll get 90. So kind of thinking through the graph in your head, writing out the graph, or doing the algebra. Doesn't matter to me how you do it. How many had 90 there before I got to it? Questions on it? I can leave the standard deviation blank. So let's say z-score equals 1.5, mean equals 10, x bar equals 22. Find the standard deviation. Look at us doing math in an AP math class. This is crazy. Doing algebra 1 in an AP math. So z equals x bar minus mu over sigma. So 1.5 equals 22 minus 10 over sigma. So I think you can think about it as cross multiplying, or just multiply both sides by the sigma. But either way, you end up with 1.5 sigma equals 1 times 22 minus 10 is just 22 minus 10. So it's just 12. And if you divide by 1.5, your standard deviation should be 8. And if you're not sure, just like make a little sketch of a graph. And if your mean was 10 and your standard deviation was 8, 22 would be right there, which is, right between 1 and 2 standard deviations. So 1.5 makes perfect sense. I'm at 1.5 there. Questions? Which one am I missing here? The mean. I could leave the mean blank also. I didn't do that yet, right? Alright, so let's say z equals -3, x bar equals 40, standard deviation equals 100. No, standard deviation is 10. Find mu. See if you can do it without the formula. Like, see if you can just think through it right now and get a number, and then use your formula to kind of check your work. So you're 3 standard deviations below the mean. Can you work backwards in your brain and figure out where the mean was? So just thinking through it, if you're 3 standard deviations below, and every standard deviation is 10, how much below are you? It's 30, right? And if 40 is 30 below the mean had to be 7. So that works. That gets a little tougher when it's like weird decimals and stuff, so you want to know how to do it also, but I think you can understand it a little better if you can reason through it. So that'd be my setup. Add multiply both sides by 10, so -30 equals 40. minus mu. Let's say I subtract 40 from both sides. So keep in mind that's negative 70 equals negative mu, which means mu would actually equal 70. Somebody had 70 there? Alright, questions? Alright, I'm making up a little table for you. I want you to fill in the missing stuff here. Still a work in progress. The sketch is kind of optional. It's for you to, I don't care if you draw the sketch. I care that you find the missing box in each one of these. I think the sketch is helpful, but I'm not going to force you to use that. So I want you to try to fill in the blanks there. I'll try to do it without the formula. Just kind of thinking through it. If you get stuck, you have the formula to fall back on. But again, if you do it without it, you're practicing like the understanding of it a little better. No, that is not usual. Number 2, did you get a negative? Did you guys get a negative standard deviation? That shouldn't happen. That means I'm an idiot and wrote the question wrong. Let's do z is negative 2. That's my fault. You won't get a negative standard deviation. That's not possible. worksheet. I can't tell if you guys are working on this or the worksheet. Raise your hand if you're done with. It's fine if you want to start. I just don't know when to go on. Raise your hand if you're done with this. Raise your hand if you want more time for this. Okay, I'll wait a couple minutes. Go ahead and start this. I don't care. It's hard for me to tell. That's like the data point. You just answering your question. You got all snooty about it. I'm gonna go through it too, but I'm just waiting until people are done with this. Kind of how'd you guys do? Friday or Sunday? Not well. Really? Not what you were hoping for?
Well, when it's a gross seal, we're in their top 6, and they never do that. So
It's like how many standard deviations.
Did they beat you?
Like,
Was it close? Not really. Really.
it's like right there, it's like one standard deviation.
How'd you do? What was your time?
You just do
No, we
it
were
was slower than Thursday, but I put everything on Thursday, so.
So you'd more like recover, yeah.
the actual data point is
Does he tell you like today is when you should like really go after it? Like today you should save it for now.
I mean, sometimes he'll, like, I suggest you go a little bit faster today,
Okay.
go on a little slower, but it's not every race.
Okay. What's your PR?
Like, overall.
Yeah.
21.50.
2150. That's pretty fast. It's like how long it takes me to get to the senior wing. Alright, so I'm gonna put the answers up to this, kind of talk through it, and then I'll go through what I want you to do in that worksheet. So I feel like I lost this. Some of you guys are ahead, some of you guys are not. That's okay, as long as you're getting it. So here your mean is 80, your standard deviation is 10, so you're going to go like every 90. And then 95 is right there. So that's going to be 1.5 standard deviations above. And you can certainly use the formula to get that. I'm just trying to talk through the intuition of it. Z-score here is -2, so if you went 2 standard deviations below, and you're at 5, and this is 2 standard deviations below, then each standard deviation must have been 1.5. That's the only way it would split up the right way. And again, you guys talk, use the formula. Here I got a mean of 0. I'm at 10. And that represents 1.5 standard deviations. So you got to do 10 divided by 1.5, which is 6.66666, yeah. So your X bar here would be 6.6666. Repeat. What? Oh, yeah, no, I did it wrong. Yeah. The standard deviation is 10. And you went 1.5 standard deviations. So the standard deviation is 10. You went one of those and then another 0.5. So you're right, it is 15. My fault. And then the last one, so the mean, I don't know. I know that I went 2 standard deviations down, and each standard deviation is 50, so I'm at -100. Or I'm 100 below the mean. And I'm at 50, so if I'm 100 below the mean and I'm at 50, the mean must have been 150. And again, the formula works on every one of these. I'm just trying to reason through it. Sure is. Questions on anything on there? Alright, so let me go through a couple of the ones in the worksheet, get you started on that, and then I'll give you time to finish it. So you're doing really similar stuff. I do want you to throw a sketch in here also. Again, just trying to get used to like what it means and what it looks like. So the mean ACT score is 21. Standard deviation is 3. So I'm going to go 24, 27, 30. And then the same thing in the other direction. So this is your mean. You scored a 26, so there's kind of a specific way I want you to write this, and this is, it doesn't really matter now, but it matters next semester, basically. I want you to go right here to where the 26 is, and down here, write X bar equals 26. And then up here, write whatever your Z-score is, which we'll have to find. But but I want the X bar and the Z labeled on the graph, and in this way I prefer it, with the X bar down below and the Z score up the top. And there's a reason for that, but I won't really get into it until like January, so for now just take my word for it. For the Z score, we're going to have 26 minus 21 divided by 3, so 5 over 3, so this is like 1.67. 5 over 3 is totally fine. So, what we're going to start doing this is, okay, what percent of the data is below that, what percent's above, or what percent's between this and this, that's where we're headed. But just getting you to like set up a graph, look at where you are, what it means, standard deviation, all that stuff. Some of them are a little different, so if you look at number 3 with me, I just gave you a different piece than I did in number 1. Might be going too fast. Are there any questions on number 1? Am I going too fast or we're good? Somebody freaking say something. Alright, thank you. So I got a mean of 120. I'm on number 3 now. Mean of 120. Standard deviation's 30. So you're going up 30 3 times and down 30 3 times. And your z-score is 2. So this lands right on one of the numbers, right? So my z-score is 2. And then I didn't leave much space, but my x-bar, I don't need the calculations, really. What's my x-bar? It's 180, isn't it? 2 z-scores above the mean, like I'm looking right at it. 1 above, 2 above. So same idea, you're still putting the x-bar and the z-score and making the chart. Those are kind of like the 2 different setups. I don't think I left anything blank except z-score and data point. Questions on that? Alright, thank you. So then tomorrow we'll keep doing some more stuff, but you have the rest of today to finish this, and I'll do it also so you can check it. X bar is your score, or the data point. here's what I got for 2 and 4. I can show you the back a little bit. You can come up and look at it if you want. Ask me a question if you'd like. Make sure you have your calculator tomorrow with batteries. You're gonna be like, it'd be useless if your calculator doesn't have batteries tomorrow. Sands on you didn't